This is the Earth's atmosphere when viewed from space. That thin blue line at the edge of the planet is all that stands between you and the vacuum of space. The Earth is an approximately spherical ball of rock, about 12,750 kilometers across, and our atmosphere is really a thin skin across the surface of the planet. It's a bit hard to get an exact thickness of our atmosphere because the outer edge gradually fades into the vacuum of space, but most people accept that it is about 100 kilometers across. Almost all of our weather and our experience in the atmosphere is limited to the first 40 kilometers. We can look at the structure of our atmosphere a little more closely in this diagram. Commercial airlines fly between 10 and 15 kilometers up. Military aircraft can fly up to twice that, and above 30 kilometers, all you'll encounter will be a couple of weather balloons. Without the safety of an aircraft, humans struggle to breathe above a few kilometers into the air. The highest permanent human settlement is La Riconada in Peru, and that sits about 5,100 meters above sea level. And although humans have walked on the top of Everest without oxygen, which is nearly 9 kilometers above sea level, they have not been able to stay there for very long. And so it is just these few kilometers of air that keep us alive. Now, I should point out that the examiner will not ask you to recall the dimensions of the Earth's atmosphere. However, it is important for you to have a sense of scale for the planet you live on and the vital nature of those first few kilometers of air. The examiner will ask you about the composition of today's atmosphere, which is a mixture of three main gases. You need to know their names and the percentages of each one. The composition may surprise you. First of all, the most common gas by far is nitrogen and not oxygen. Discounting any water vapour that we might find, our air is approximately 78% nitrogen. The next most common is oxygen at 21%, and the last 1% is mainly the inert gas argon. Now, you hear quite a bit about carbon dioxide in the news, and of course it's carbon dioxide that we breathe out, that plants require for photosynthesis, and that we release when we burn fossil fuels. But in actual fact, carbon dioxide makes up only 0.04% of our atmosphere. Thinking about that 0.04%, we should talk briefly about units. Scientists and examiners may use another unit. 1% is the same as saying 1 part out of 100. And so 0.1% would be the same as 1 part out of 1,000, and 0.01% would be the same as 1 part in 10,000. The examiner will talk about parts per million. And so 0.04% is the same as 400 parts per million, or 400 ppm as it gets written down. Now, you won't be asked to convert between percentages and parts per million, certainly not without the examiner giving you a formula, but you do need to be aware of this unit, as it might turn up in tables, graphs, charts, or in the text of an exam question. There are also other gases in our atmosphere, principally the remaining inert gases. Neon, helium, and krypton all make up tiny amounts of it, along with about 1 to 2 parts per million of naturally occurring methane. Other gases are generally referred to as pollutants, and we'll talk about them in later lessons. So this is the air we breathe, and despite the fact that human activity and atmospheric pollution has made some changes to the atmosphere over the last few hundred years, The actual size of those changes, relative to the main gases in the atmosphere, are tiny. In fact, the percentages of the common gases in our atmosphere have hardly changed at all for the last 200 million years, and that's all the way back to the time of the early dinosaurs. The examiner quotes the following basic figures: that for the last 200 million years, our atmosphere has been approximately 4/5 nitrogen, that's around 80%, and 1/5 oxygen, that's 20%, and small proportions of other gases, notably carbon dioxide, water vapour, and the noble gases. The examiner could choose to use fractions, percentages, or even ratios in their questions. So it's also worth noting that the ratio of nitrogen to oxygen is pretty much 4:1. You should make sure now that you can recall the percentages of the gases in the atmosphere and be familiar with those numbers as percentages, ratios, fractions, and also parts per million for the rarer gases. Take some time now and learn those off by heart, so it will be easy marks to get in the exam. In the next lesson, we'll be looking at where our atmosphere has come from, and we'll be taking you right the way back to the early days of our planet to explain its origins.